Raspberry Pi. In this section, we will host our backend server from a Raspberry Pi instead of using Firebase functions. We will be doing two projects. One, you will print something that you say on a LCD screen, and two, you can ask for sensor readings connected to your Raspberry Pi. LCD connection. In this lecture, you will learn how to connect an LCD to your Raspberry Pi with the I2C header. You will also learn what is I2C protocol. If you had already been through my previous introduction course, then by this time your Raspberry Pi will be ready with most of the setup process done. I will still give a quick recap so that anyone can follow up. First, you will have to install Flask into your machine using pip installer. And then for tunneling your localhost created using Flask, you will have to install a tunneling tool. I have used Beam. Create an account in the Beam InstaSSL site and also download the same into a machine using the npm package manager. Now let's move into our current project. Here we are going to print things that the user says into the 16x2 LCD that will be connected to the Raspberry Pi. First of all, create a new intent in your Google agent. I will name that intent LCD printing. First, create a new entity to hold the content to be printed. I will name the entity data. Since this content can be anything, use system.any. And then, in the training phrases, use the entity with the word print by annotating the content after the word print. Then enable the fulfillment of your intent and save the intent. I have used a 16x2 LCD with an I2C header fitted to it of connecting an LCD to the Raspberry Pi. I2C is a serial computer bus. It is widely used for attaching lower speed peripheral ICs to processors and microcontrollers in short distance, like intra-board communication. Here, the I2C is facilitated using the PCF8574 IC, which acts like an 8-bit expander. Thus, we can communicate all the 8 bits of data to be displayed through the serial data line and the serial clock line. In our Raspberry Pi 3, board pin numbers 3 and 5 are SDA and SCL respectively. So the connections are pretty simple. Connect the SDA and SCL of the I2C header to the SDA and SCL of the Raspberry Pi. Give the 5V power supply to the VCC of the header and the ground to ground. As simple as that. Once the connection is done, move to a PuTTY shell. Quick recap again, PuTTY is a secure shell using which you can access the terminal of your Raspberry Pi remotely from your network using the static IP you have set in your Raspberry Pi. Once you are inside the terminal, you need to enable the I2C in your machine. Type sudo rasbconfig in your terminal and press enter. This will take you to the configuration page. From there, move to the interfacing options and enable I2C. The next step is to install the I2C tools that will help us in finding the address of the device connected. Download the I2C tools using the command sudo apt-get install I2C tools. Finally, you need a Python library to access the connected device from your Python script. Download it using the command sudo apt-get install python-smbus. Now reboot your Pi so that you can check whether your proceedings till now have been correct. Once rebooted, run the command I2C detect -y1 and it will show you your I2C device address, and as shown, 3F is our hexadecimal device ID. I2C potentially allows many devices as long as their addresses don't conflict. Now let's move into the Python program. Summary. In this lecture, you are introduced to I2C protocol and also how to connect your LCD to the Raspberry Pi with the help of the I2C header. In the next lecture, you will learn the Python code involved in this project.